So far, we have seen using functional interfaces as object variables, returned as object variables, and we have called operations or methods on them on the functional interface. So next we will look at using functional interfaces and passing them as method arguments. So for that, let's write a class. It's new class, say calculator test underscore method arguments. All right, with a main method. All right, we'll write a static method here. Public static void calculate. You can say calculations otherwise, right? Yeah, that's appropriate. Sounds like appropriate one. Void, and we'll print the results here itself. So we will no return, or directly we'll print the results. Let's get rid of this argument. We don't want. Let's see calculator test for a reference. Yeah, method arguments, right? So we'll pass in two functional interfaces over there, arguments as arguments. Let's see, one is addCalc and multCalc of type calculator again. And then this is also multCalc, is also talking of a functional interface called calculator in this case. Okay, and we'll invoke the operations here. Calculate. And another one that is multCalc or calculate. Let's come back to it later, a little bit after, and we'll complete that. And now we'll focus on passing the arguments so to the calculations, or you could say, yeah, here calculations. Okay. Dot calculations. So this is static, public static method, so we'll just take the class, and we don't need to instantiate the class, and just call calculations. See, this is italicized, so this is static method. And now what we'll pass is, let's see the reference here. Directly you can pass the lambda expression here for addition. Okay, we don't need that semicolon over there. Another one is for multiplication. So in one sense, we want it to behave these first argument as additional add behavior and this multiplication behavior. All right, so we have got, okay, we have got calc, we are already passing this, and then calc. What did we do here? We need to pass in the, we are passing this behavior, expected behavior here, but we need to pass in the actual numbers here, right? Again, let's pass in 5 and 10 to the addition, and then 5 and 10 to the multiplication. Okay, but in calculate method, do we have system.out.println? No. So we need to calculate, return the integer int add result and in this case it will be mult result, let's say. All right, just need to print them out together. System.out.println add result, that is add result, and mult result equals mult result, the value. Okay, what do you think? Would it run? Let's try it. Just say control 11. Yeah, it printed 5 plus 10 15 here, and here multiplication 5 multiplied by 10 is 50. We'll just give some indentation, so run it again. It looks better. All right, it looks better, much better, right? Yeah. Zooming it for you so you can read it clearly. This is the package, and we have just written one static method called calculations, and passing the two arguments as two functional interfaces. And here from the main method, since it's a static method, we can just call with the class name dot static method name. So that's what we are doing here, calculations, right? We are calling this calculations, so this will be invoked as static method, and we are passing the behaviors here, x plus y and then x multiplied by y. All right, now let's look at an exercise. So anonymous runnable. So in Java we have a runnable interface already available to create the threads, in one of the ways to create the thread. And since it is having only one method called run, it could be replaced by Lambda, right? So we will see the part 1, write an anonymous class implementing a runnable interface, right, that prints hello world 1 simply, right? And 2, we will replace it by Lambda using runnable interface again, but this time using the Lambda. This time using the Lambda, this time we'll print hello world 2. So anonymous runnable, right? Yeah. So we'll create a class called anonymous runnable test. Let's get back to Eclipse. So we'll create a package first. Anonymous. All right. Anonymous replacement. How about that? Yeah. Anonymous dot replacement. Okay, and here we'll create a class anonymous runnable test with the main method, checkbox main method. Here we are. Okay. Okay. Here we'll create an anonymous class first. New runnable here we already have it. The body or the block is ready in the run method, which is overridden, right? Here you put sys out hello world -1. All right. Alright, this is all happening in the static main method, but we'll take it into variable. Runnable run 1. Alright, you can see since this is Java 8, it's this class is already annotated with functional interface. That is interesting, something interesting to see. All right. Okay, and now we'll just invoke it. Run 1 dot run. All right. It did not yeah, we can invoke it now and run it. Control F11, hello world 1. Yeah. Next, this is one part is over. Second part is we have to replace it by lambda, equivalent version of lambda. How do we do it? Let's see. Let's write the expression first. If we see this guy, this runnable implementation block, we can see it is empty bracket. Nothing is there. So to write a lambda expression, the argument is blank in the brackets, this lambda symbol, and the behavior. Behavior will simply hello world 2. Is that all? Something is missing here. Let's see. Assignment operator expression. To complete the, we have to insert it. Assignment operator expression. So put assignment operator and use runnable run 2. All right. Next call run 2 dot. Note it. In this case run. Right. Again run as we did here. Now run the whole program again. Control F11. You see here hello world 1, hello world 2. I hope it is clear. Let's move forward.